All right, welcome back. Yeah? Do well on your quiz? Yes?
Yes.
No? No? Remember yesterday we were here? Let's do another problem, shall we? Gabby, you're smiling. Good. That's a good sign. Everybody ready? Okay. Right. What I want to talk about today is pressure. I don't mean pressure of taking a test. I mean pressure of a force pushing down on some area. If I take this pen and I push it, it might go through my hand because there's a large force but a very small area, correct? Yes? So pressure is force per area. Now, I want to look at the relationship between force and pressure and area and force and area. Okay? Now, to do this, I have some information on the board. Okay? I am 220 pounds. I know. I look great for 220 pounds, don't I? Okay? 220 pounds, I am. Now, I'm standing on shoes. Can we say that these shoes are about a square foot? A little more than a foot, a little less than a foot, about a square foot. Can we say that? So we can say that my pressure on the floor is 220 pounds per square foot, correct? Yes? But we don't use pounds per square foot. What do we use? We use newtons per square meter. Force is newtons, area is meters squared. Because we use newtons, we use meters, we use kilograms, we use seconds. Nowhere in there do we use pounds. Correct? But since this is the United States, we sometimes use pounds. Okay? All right. So the first thing I want to do is just to give you a little bit of a review on factor label to convert from pounds per square meter to newtons per square meter. I'm sorry, pounds per square foot to newtons per square meter. I want to convert, okay? Yes? Yes. Okay. So I change the pounds to newtons, newtons to kilograms, kilograms to newtons. Correct? So let us put that N, we'll make that a different color. So that's newtons. Okay? Now, I get rid of the square feet and I go to square meters. There's 10.76, 11, we can say 11, but 10.76, correct? 10.76 square feet in a square meter. Does that make sense? Right? Like a yard is 3 feet, right? A little bit less than a meter. So 3 feet by 3 feet is 9 square feet. Meter's a little longer, so that would be a little larger. So that makes sense. Does that make sense to everybody? Yeah? Okay. Now, I multiply this out. I get 10,760 newtons per square meter, otherwise known as pascals. Pascals. What is that named after? It's named after Mr. Pascal. Of course. What was Mr. Pascal's first name? Anybody? You'll never get this unless you know it. Blaise. Blaise Pascal. Okay? P.A. Pascal. Okay, now, I'm going to erase some of this, okay? I'm going to erase this. I'm going to erase this. I'm going to erase this. Okay? Now, let's discover something. Let's talk about this equation. Pressure equals force over area. We'll talk about pressure when we do fluid dynamics a lot. But this particular author in our book talks about pressure, so we have to talk about pressure. We're not going to spend a lot of time on it, but we have to talk about pressure. Is that okay? Yes? Okay, now, let's say I go on ice. Slippery, right? But I have shoes on. It's not that bad, but you just got to be careful. You can do it, right? but it's slippery, right? But what happens if I put on ice skates? What happens when I put on ice skates? Let's think about that. All right? Let's think about that. Yes?
The surface area is less.
The surface area of the ice skates is less. Excellent. Absolutely. Absolutely. Let's see how much less it is. Let's approximate it. Ice skate, can we say that an ice skate is about a foot long? Could be more than a foot, less than a foot, figure skates, small skates, racer skates, hockey skates, but can we agree that it's about a foot? How thick is a skate? About 1/8 of an inch? Yes?
Yeah.
An inch is pretty big. It's like an inch right there. That's it. You know where the inch comes from? Comes from this. Right there. That's an inch. Right? Right there. That's an inch. Okay? It's an inch. Now, so 1/8 of an inch, is that reasonable?
Yeah.
Is that good? Yes? All right, now. So 2 skates would be 1/4 of an inch. Correct?
Yes.
Is that easy?
Yeah.
So what's the area? 1 foot times 1/4 of an inch, right? Yes? Length times length. So 1 foot times 0.25 inches. Yes? Is there a problem with that though? The problem is I have feet in inches, don't I?
Yeah.
What I got to convert 1, right? So I'm going to convert the inches to feet. Is that okay?
Mm-hmm.
All right? Now, how many people in here do not know? I have a lot of different nationalities in here. How many people don't know how many inches there are in a foot? Anybody? All right? How many inches are there in a foot? Everybody? 12. Excellent. So, 0.25 inches times 12 inches, 1 foot. Inches cancel, I'm left with square feet. Now, I've done this calculation already in my last class, so I know what it is. I could fool you. Mental math, 0.02. Is that okay? You want to do it? 0.25 divided by 12. About 0.02, right? 0.02 square feet. Is that okay? Is that okay? Yes? Okay. So let's erase that. And we're just going to put this over here for a second. We're just going to put it up here. We're going to hide it. We're going to hide it. Don't tell anybody it's there. We're going to hide it, okay? Right? What was that magazine where you find out the different things in the trees? Yeah? We're going to hide it. We're going to do one of those. We're just going to hide it, okay? You ready? We're going to say 0.2 square feet. Okay, now, let me change gears here just for a second. Chemistry. Rewind the clock. Wind it backwards. Chemistry, your favorite class. How many people have as a favorite class? There's no one raising their hand. Okay? All right. Now, Gay-Lussac. Anybody remember that? Gay-Lussac? Gay-Lussac. Gay-Lussac law. What is the Gay-Lussac law? What is it? What is Gay-Lussac law? I'll tell you. You don't remember? No? What'd I tell you? If I take a volume of gas, a fixed amount of gas, and I compress it, what am I doing to the pressure? Am I increasing it or decreasing it? I'm increasing it. But what is pressure? Pressure is the molecules hitting the container, hitting the walls of the container. Isn't that what pressure is? Yeah. Right? Well, what's temperature? Temperature is similar, isn't it? I increase the number of collisions, the frequency. It's going to give up its kinetic energy, the molecules, and I'm going to get heat. Right, good. So I increase the pressure, I increase the... and you thought you didn't remember. Excellent. So increased pressure, increased temperature. Yes? Increased pressure, increased temperature. I have a piece of coal down deep in the earth, and I put a lot of the pressure of all that rock, and that's going to heat it up too, and I'm going to get a change in the structure of the carbon, and I'm going to produce what? Starts with a D. Diamonds. Okay? Yes? Diamonds. Now. So what? Wait. Wait a second. We were talking about Newton's laws, force per unit area. Now we're talking about Gay-Lussac, and we're talking about pressure, temperature of gases, making diamonds. What is going on here? What's going on? Well, I'm going to tell you. All right. Let's go back to our area, the skates, okay? Is that all right? Can we do that? Yeah? Okay. So, 220 pounds over 0.02 square feet. What does that equal? I know, mental math. 22 over 0.02, yes? Around 11,000?
Yes.
I already did the problem, I know it already, but don't tell them. Okay, 11,000. What? 11,000 what? 11,000 pounds per square foot. I went from 220 pounds per square foot to 11,000 pounds per square foot. I'm standing on that ice. I'm increasing the pressure. What am I doing to the temperature of the ice? I am increasing it. Question. Do you skate on ice or do you skate on water? You skate on water. You don't skate on ice. The ice skate will melt the ice. So let's talk about the relationships between the various things that make up pressure. Pressure equals force over area. All right? Area and pressure. Area and pressure. Direct or indirect? Direct or indirect? As I decrease the area, what am I doing to the pressure? I am, as I decrease the area, I'm going to increase the pressure, aren't I? Right? Yes? No? So that's indirect or direct? Indirect. Indirect. How about force and pressure? How about force and pressure? As I increase the force, what do I do to?
Increase the pressure.
They're direct.